Hi, we are Team Wreckers and we are building AlgoPay, payment infrastructure for AI agents on Algorand. Agents need to pay in USDC. They may need to call paid HTTP APIs with X402. And while doing so, they need to stay inside spending policies with an audit trail. What we are building with AlgoPay is the infrastructure that AI agents will need to perform such said actions. With AlgoPay, you get two things: SDKs in Python and TypeScript in your agent process, and an optional console as well for teams that want vaults, API keys, and dashboards. I'll be walking you through how the AlgoPay SDK works in Python. So here we install our AlgoPay SDK from PyPy. The distribution is named as AlgoPay-SDK, and you just need to import the AlgoPay class. Here we are initializing the AlgoPay client. AlgoPay defaults to Algorand testnet and public Algor indexer endpoints. You don't need any API keys for reading on-chain data. How we build the SDK is that each agent gets a wallet set and a wallet. Local Algorand key pair. Key stays in this process unless you plug in your own storage or use the hosted console vault. As you can see, a wallet was created for your AI agent. If you already have a wallet that you want to import, you can do that as well with the SDK. The balances are in USDC on testnet ASA, not Algo. You need Algo separately for transaction fees. For payment routing, one pay function API routes by recipient string. A 58 character Algorand address uses a USDC transfer, and an HTTPS URL uses X402 pay per call. This is where things get interesting. We have implemented spending guards. Guards run before we touch the chain. Here, a recipient allow list block a payment to an unknown address. It shows up as blocked in the result and ledger, not as a failed on-chain transaction. You can see that since this no was not white, this a wallet address was not whitelisted. The SDK, our SDK has blocked the recipient. Now, AI agents can simulate before spending, guards, balances, and routing without submitting a transaction. With every pay function call, writes a ledger entry, pending, completed, failed, or blocked transaction for operator audit and agent memory. Uh, we have already funded this wallet, so we don't need to run this cell. So with the pay function with an Algoland address, we submit a USDC asset transfer. We use a small self payment so the receiver is already opted in. So the USDC transfer was the same. And for live export to pay per call, this same pay function accepts an HTTPS URL. AlgoPay runs the Algorand export to exact scheme, discover, pay in USDC, fetch the resource. We have also implemented a concept of payment intents. Intents separate authorization from capture, like holding funds before you confirm the purchase. Confirm runs the same routing as pay. We have also added the feature of batch pay, runs multiple payment requests with a concurrent limit. It's useful when an agent settles several invoices in one turn. There are also functions to like list transactions that reads recent on-chain activity for the wallet from Algorand indexer. And there are also functions to save your wallet. This is the demo of the merchant dashboard and workspace overview of payment volume and settlement method. The testnet is our default chain at the moment. Uh, you can go to settings. In settings, operators create an API key for the agent. Same idea as production API security. Your agent calls our agent pay endpoint with bearer authentication and no private keys in a codebase if you use server-side signing. Spending policies here mirror SDK guards. Max daily USDC, max per transaction, approval threshold at the workspace level. Wallets are vaulted on the server. We generate the algorithm address here. Funding is a separate operation step. Balance reads the chain when you connect it. Under APIs, you register X4 to endpoints. Your agents are allowed to hit URL, slug name. Agents can call through the workspace proxy, for example, the X42 demo weather API here, instead of hard coding paid URLs in every agent. Agents tie a name, address, daily limit, and gas pools to a registered spender. And Playground lets you hit the REST API from the browser. Here, list agents without writing any curl command. So the SDK for agents, uh, your stack, wallets, USDC, guards, X42 ledger, on PyPy, etc. And console is for operators who want keys, policies, vaults, and API catalogs all in one place. They both go hand in hand, but you can comfortably use either one without using the other. This is the entire ecosystem that we are reimagining